So we are working on 1.4 part 2, right? And we are we're starting with domain of function. Last time we talked about functions, and now we are talking about the domain of a function. The domain of a function is all the things that our input can be, right? So if I have a function that's like f of x, x here would be my input, right? Anything I can put in for x is my domain. Like any value that I can have for x would be considered the domain of that function. And then the output, whatever I got back out for y, right, would be my range. But today we're just talking about the domain. And the domain is everything x can be, right? Everything my input can be. So if I had a function that was like f of x equals x plus 1, well, I have no limit to what I can input for x in something like this, right? I could put in anything from negative infinity, I should say negative infinity, all the way to infinity for x, right? There's nothing limiting my x. There's no rules on x plus 1 that prevent me from putting it in. So I could have all real numbers, right? Yes, to infinity and beyond in both directions, right? That's the beyond. It can also be negative infinity. We would call that all real numbers, right? And you can write it as all real numbers, or you could write it as the set of all real numbers, or you could write it as negative infinity to infinity are all potential x values, right? Because I can take any number and add 1 to it and still get a number, right? Um, so we're going to look at things where the domains might not be all real numbers. Because what you're going to be asked in your homework for part of it is to find what the domain of a certain function is, right? And so we're going to find the domain of each function. So basically, what we're looking for is what are our limitations on x. So if I am given a set, if I have f and I am given a set of uh, points, right? So I have -3, 0. I have -1, 4. I have 0, 2. I have 2, 2, and 4, -1. 2, 2. That's supposed to be a 2. Forget that little mark I made there. 2, 2, and 4, -1. The domain of this function right here would be all of our x values, right? Our domain on this one would literally be the set of numbers. You go domain equals, and we can make the set, and it would be -3, -1, 0, 2, and 4. Because those are all of our input values. Those are all of our x values. in our x values, that first coordinate point, that first part of the coordinate point would be our domain. If I asked you the range on that one, you would give me all of the y values. But it won't always be set up like that. Sometimes we're going to get things that are a little crazier, like we will get b is g of x equals 1 over x plus 5. So when I look at a problem like this and I want to know what is the domain of this function, I have to kind of understand my rules. And what can I not divide by? What number can I not divide by? Right, Kevin. Kevin says 0 in the chat box. So what would make that denominator 0? So I have x plus 5. What would make that? Yeah, right? Kevin says -5, which makes sense. If I had x plus 5 equals 0, I would subtract 5 from both sides. So x equals -5 is the one thing we can't have, right? Anything else is okay in the denominator. Every other number is okay to have in that denominator. So there are different ways I could state this. The only thing I can't have is something that makes that denominator 0, right? Because we can't divide by 0. It's getting hot in this room. So we know we can't have -5. So I could write this as infinity to -5 in union with -5 to infinity. I'm using parentheses because we're not including -5. If I don't understand this notation, also a correct answer would be all real numbers except 5. Except -5, right? But at this point, I think you guys should be fairly comfortable with notation like this. I would hope. Fingers crossed on that. Right? What does this mean? It means we go from negative infinity, like we can go as far as we want. Any number, any real number is good, right? Except for -5, which we aren't including. That's why it's in parentheses. And again, we could start again at -5 and go all the way to infinity. And all it says is that we're not including -5 because we cannot divide by 0 because it will clearly disrupt the space-time continuum. If we did it, none of us would exist anymore. So what you're looking for are certain rules, right? That make things true or false. So that's all that they're asking for when they're asking for a domain. What can X be? That's all you're trying to find out. I'm not going to choose problems that are super difficult in that respect. I'm probably not even going to go in terms of the application problems. Something just came to mind. Evaluating difference quotient. Where's the? I'm gonna do that with you guys. Did I miss a part? Oh, I did. I started on the wrong page. I jumped into domain when I wasn't ready for that yet. Another thing we're going to be talking about is what we call piecewise functions. And we did piecewise functions in Algebra 2. We didn't spend a lot of time on it. But a piecewise function is just you're going to follow a certain rule when x is one thing, and you're going to do a different thing when x is something else. So a piecewise function is literally pieces. Piecewise function will state that if I have a piecewise function that's f of x equals, and you'll see something like this, and it'll have 2 or 3 different equations in it. So you have x squared plus 1 when x is less than 0, and x minus 1 when x is greater than or equal to 0. And it just means if I have a value of x, I want to know what happens when x is that number. So say if I have to evaluate it at x equals -1, x equals 0, and x equals 1, right? Well, at f of -1, hardly looks like a -1, we're going to look over here and it says if x is less than 0, we are going to use x squared plus 1, right? If x is less than 0, we're going to use x squared plus 1. So we're saying that x is -1, so I'm going to have -1 squared plus 1, which gives me 1 plus 1, which equals 2. At f of 0, well, here it says if I have x greater than or equal to 0, I'm going to use x minus 1. So we would have 0 minus 1, which just gives us -1. At x equals 1, right, we're going to take the bottom function again, right, because 1 is greater than 0. And so we're going to go 1 minus 1 equals 0. And so that's all that's determined in a piecewise function is you're going to be given a set of equations with rules on them, right? One might say when x is less than 0, and you'd perform that function equation when x is less than 0, and it's going to give you a set of values to find when x is that number, and you have to pick which equation you're supposed to plug it into. It's not super difficult, but a lot of times people see this with the multiple equations and they don't know what to do. All it's telling you is based on whatever number we're giving you, which equation am I going to use to solve it? Does that make some sense? Yeah. Yeah, it's not terribly difficult, but trying to see how much time we have because I have a couple more things to go over with you. I'm going to finish this today. 1:12. We got some time. We got enough time to get through it. The other problems you're going to have are you're going to have something where they're going to ask you to find values. For which f of x or whatever function equals 0. All that means is whatever function they give you, set it equal to 0 and solve it. It just means if I have f of x equals minus 2x plus 10, and they're going to ask me to solve it for when f of x equals 0, I'm just going to take this equation and I'm going to set it up equal to 0 and then solve it. All right? That's all that it's asking. What did I do? I replaced f of x with 0. Yeah, I put it on the other side of the equal sign, but it's an equal sign. I could put it on either side, right? They'll still be equal. And then I can just go ahead and solve for x, right? I subtract 10 and subtract 10, and I get negative 2x equals negative 10. And I divide by negative 2, divide by negative 2, and I get x equals 5. Right? And so I can solve these problems. They're not that new. Like, none of this is new. It's just to understand what it's asking for when you get to problems like this. You might also find some that say, and I say might, but you actually will, right? For finding values for when f of x is equal to g of x, right? It's going to ask you to solve when f of x equals g of x. Well, if I'm given a problem that says f of x equals x squared plus 1, and g of x equals 3x minus x squared. If f of x equals g of x, I could just say x squared plus 1 equals 3x minus x squared, and then go ahead and solve for x, right? If f of x equals g of x, I could just take this and set it equal to this and solve. That's all that it means. So when it says if f of x is equal to 0, you just take whatever equation they give you up here and set it equal to 0 and solve. Here, when it says f of x equals g of x, just take whatever equation is set equal to f of x and whatever equation is set equal to g of x, and you can set them equal to each other, right? And then we can go ahead and solve it, which, I'm going to do minus 3x over here. And I get x squared plus, x squared minus 3x. I probably should have moved my 3x first. X squared minus 3x plus 1 equals negative x squared. I can move this over too. I could add x squared to both sides plus x squared. And then I'm going to get a 2x squared minus 3x plus 1 equals 0. And I can solve that using the quadratic formula, or I could factor it. This is a pretty easy factor, I think. We could go like 2x minus 1. And what, x minus 1? I think those would work as my factors, and I could set each of them equal to 0 and solve. Will they all be this complicated? No. But if you don't know how to factor it, if you can't remember how to factor, you can use the quadratic formula. But I found this to be a pretty easy one. Then I could set each of my factors equal to 0, and I'd get x equals 1/2 and x equals 1. But the more important part of that is understanding, how do I set it up? So we went through domain, we went through piecewise, we went through all the types of problems I think that you can get. I'm going to make an assignment out of that, but I'm going to push the deadline on it. And I would love it if you guys took a shot at it before our next class, so that if you have problems, we can go over specific problems before you guys head into the weekend. And if not, I'm going to assume you guys are ready to just move on to the next thing. But otherwise, if you have some problems with this assignment, I would like to be able to go over them with you before they're due. Fair enough? Since I kind of pushed you into this one a little bit. Beyond that, I think that's about it. So unless you guys have something else you want to talk about or have some questions you want to ask,